Cool. So I'm Ethan Jackson. Before I get into what Quilt is, I'm going to introduce myself a little bit. I am brand new to Node.js and JavaScript. My background is actually in computer networks and distributed systems. I spent quite a few years doing low-level C hacking in industry before I started working on my PhD at Berkeley. And Quilt is a project that we started in our lab to make it really easy to deploy distributed systems like would use Node.js to the cloud. So I'm super grateful for the chance to speak at SFNode and talk to all of you and hopefully get your feedback on this project and get your perspective on it. So first, the motivation for why we built this. If you think about the cloud, it was a dramatic improvement of how we deployed applications before, physically racking servers and whatnot. But we generally had the idea at Berkeley that it's still too difficult to deploy applications to the cloud. If you build a Node.js application with a load balancer and a database that you'd like to get running, you basically have two options that I think aren't ideal. So the first option, you could deploy directly to a cloud provider, which involves reading a massive amount of documentation, learning the cloud provider's API, learning details of the internals of the system you'd like to deploy, followed by a massive amount of manual labor, booting VMs, installing software, configuring the network. And then you better hope you got the security right. You better hope you deployed it in such a way that you can deal with failures properly, et cetera. So this is not ideal. The other option you could try is to use a platform as a service, something like Heroku. And I hope you all know what a platform as a service is. Basically, you sort of hand them your code, and then they take responsibility for running it for you. And this does dramatically simplify things, but you pay for it, right? It's much more expensive, and especially gets more expensive as you scale, and it's inflexible. So if you try to do anything that Heroku hasn't planned for you, you can't. So Quilt overall, the goal of the project is to be the best of both worlds, right? We'd like to allow you to deploy applications to the cloud with the cost and flexibility of going directly to Amazon or Google, but the ease of use of a platform as a service. There's a bunch of other sort of like academic nonsense that went into this project that I'm not going to talk about today due to time. I just really want to sort of drive home this point that Quilt is designed to be sort of flexible, inexpensive, and easy. Okay. So how do we actually do this, and why is this a Node.js talk? The key abstraction behind Quilt is something that we call a blueprint. And what Quilt allows developers to do is write a blueprint of an application they'd like to deploy in Node.js or JavaScript. And these blueprints contain everything about an application that you'd like to deploy: the compute, storage, and network configuration, and then the infrastructure you'd like to run it on, the cloud provider you'd like to use, VM type, things like this. And then users can sort of consume these blueprints to deploy their application to the cloud automatically. And what's great about blueprints is they're just standard JavaScript. So this is an example of a very simple blueprint that declares a MySQL container and an Nginx container and allows them to speak over the network. And the fact that they're JavaScript is actually, I mean, it sounds simple, but I think it's quite profound. Because JavaScript is a programming language and inherits all of the abstractions and tools that programming languages have built up over the past 50 years or whatever. So really basic stuff like being able to use variables and functions and modules, simplified describing your application over using a YAML-based config language. Also, you can sort of bring software engineering best practices to your infrastructure. So you could store infrastructure configuration in version control. You can code review it. You can do semantic versioning. And really key is you can share infrastructure config just like you share code. So an expert can write a description of MongoDB and share it with regular people like me who don't understand MongoDB that well, and I can deploy it. Just like an expert can write a description of SHA-1 or left pad, and everyone else can consume that function and call it without having to understand how to add white space to their strings. Okay, so that's the super high level idea of the project. What I'm going to do now is start off a quick demo just so you can see what it's like as a user of Quilt who'd like to deploy an application of a spec that someone else, an expert or whatever, wrote. Then I'll talk a little bit more about the internals of the project while that demo sort of hums along, and then I'll come back to the demo and then finish up. So really quick before I start the demo, I'll tell you what I'm actually going to do. So all of the demo code for this project is available at demo.quilt.io, and there's helpful instructions if you'd like to try it out yourself after the talk or later. And what we're going to show is a Node.js to-do app that I got from scotch.io. So it's a replicated set of Node.js servers behind a collection of HA proxy load balancers. Behind that, replicated MongoDB, and then all of this is going to deploy on Amazon EC2. Okay, so I will get that started. This is easy. You just do npm install -g quilt-install, and that will get you the latest release binary of the project. While that's running, I'm going to actually show you the demo code here. So this is just a GitHub repo that contains some Node.js code like any other Node.js code at demo.quilt.io. So we're going to clone this repo. OK, so the Quilt binary installed. If we run Quilt PS, we will see that nothing's running. We're having a slight problem, but it should be fine. OK. So the first thing we'll do is clone the Quilt demo repo. And this repo contains the blueprint, right? So it contains the blueprint for the infrastructure we like to run on. I'll describe what's in that later. And then the Node.js application that we like to run. I'm going to open a separate terminal window and run Quilt daemon, which starts the daemon that's actually responsible for deploying the process. If I go back here to the blueprint I cloned, it's got a bunch of dependencies. The MongoDB application, HA proxy, those are living in npm. So we have to install those dependencies just like we would any other Node application. And then if we do Quilt run, OK. So that's really all you have to do to deploy the application to the cloud. If we run Quilt PS, which shows the status of the system, we'll see that it's in the process of deploying a bunch of virtual machines, m4.larges, to Amazon in Northern California. Amazon is slow, so it takes a while to boot. So, yep.
I just wanted to ask if it supports Elastic Beanstalk. Can I launch something?
No. Our sort of approach to cloud providers, we really want to avoid vendor lock-in. So we just use the bare bones Amazon boot and stop VM API. And what this allows us to do is we can deploy just as easily to Google Compute Engine or DigitalOcean or any cloud provider, because that's pretty portable. Yeah. Any other questions so far? OK, so this is going to boot up, and the application will be on the public internet soon. While that works, I'm going to go back to the talk. OK. And talk a little bit about the architecture of Quilt and how it works. OK, so there's two core pieces to Quilt. There's the Node.js library that allows you to write blueprints. And then there's a deployment engine that consumes the blueprints and deploys them to the cloud. By far the most important part of the project is the Node.js library, so I'm going to spend most of the time talking about that. And then I'll briefly touch on the deployment engine and what it does after that. Yep?
Just to check, so your library will provide some kind of a common interface, common API that can be mapped to various vendors' cloud services.
Yeah, exactly. So we sort of, you'll see some examples.
Below which you really don't have to go to tinker.
Yeah. That's exactly the idea. Yeah. You'll see some examples of this a little bit further in the talk, so maybe ask some clarification then. Okay, so the Blueprint library. So the goal of the Blueprint library is to build up a declaration of the desired application you like to run. So what kind of compute and network policy would you like running in the cloud? It is not a procedural API. So its goal is not to actually boot the containers or stop the containers, boot the VMs or stop the containers. It just builds this declaration, and the deployment engine, which I talk about later, is responsible for moving the actual state of the world in line with the blueprint. As a matter of convention, we separate two components in these blueprints, what we call the application blueprint and the infrastructure blueprint. So the application blueprint is the thing that the developer actually cares about running. So this would be the Node.js app, the load balancer, network policy. The infrastructure blueprint is what this application actually runs on. So this would be sort of deployment-specific configuration, like what VM types to use, what cloud provider to use, things like this. And I'll show an example of that in a bit if that didn't make sense. First, I'll talk about the application blueprint, though. So this is kind of what it looks like. There's three things that you should describe in this. So what compute to run, what actual programs are going to run. And this is declared by using Docker images. So as you can see in this example, this new container object declaration says that there should exist a container running the Docker image Nginx, which is hosted on Docker Hub. You can also alternatively declare a Docker file in the JavaScript, and we'll take care of building it for you in the cluster. The second sort of key thing we have is network policy, and this is described at a very, very high level of abstraction. So for us, a network is just a bunch of declarations of what containers are allowed or not allowed to talk to who. We have a default deny firewall, so we have a rule that two containers cannot talk unless you explicitly allow them to talk with this connect method call. So in this example line of code, we're saying Nginx is allowed to initiate connections to SQL on port 3306. And then there's sort of similarly high-level abstract ways of declaring host names of services, load balancers, things like that. And then something that's in the roadmap that we're working on now is a way to describe storage policy. So right now, Quilt is sort of best for stateless applications, but we're in the process of fixing that. OK. As I said before, the application blueprint is infrastructure agnostic. So it doesn't have any concept of the cloud provider that you're running on or the VM configuration. And this is important because it makes the application portable between infrastructures. So I could develop an application and run it on my laptop using Vagrant, and then deploy it to Amazon or DigitalOcean, and have confidence that it will work because it's the exact same code running in all three places down to the actual bits of the network stack, things like that. So as a user, if you'd like to deploy a spec, you do also have to declare what the infrastructure you'd like to run on looks like. And this is how that would look. You basically declare these machine objects. You can make a bunch of them, put them in a list. And it's sort of an abstract description of a cloud provider VM. So you describe the cloud provider you'd like to run on, the number of CPUs, the amount of RAM. This SSH keys thing is who's allowed to SSH into the machine to administer it. So this is saying whoever owns the public key associated with the GitHub account EJJ can SSH into the machine. And what's really cool about this is we can sort of very simply move from one cloud provider to another. So if we'd want to move from Amazon to DigitalOcean, you just move from Amazon to DigitalOcean, and Quilt will automatically sort of tear down the Amazon VMs and boot DigitalOcean VMs. Okay. So that's the Blueprint library. We also have a deployment engine, which is responsible for receiving the blueprint using this Quilt run command I showed earlier. Booting virtual machines or tearing them down if there are too many. It sets up a container orchestrator on those VMs, boots the application you specified, and then it sort of constantly monitors the system for changes. So if a container dies, if some network ACL gets out of place, we'll sort of fix it up for you automatically. And the goal is to get it to automate as much of sort of DevOps as possible so that you don't have to deal with things manually. Okay, so if we're fortunate, the demo worked. So we'll spec, and we had these virtual machines that were declared but not booted yet. Moment of truth. Okay. Oops, I cleared my screen. Okay, so now we've got all those virtual machines that we declared earlier. And by the way, if you can't read this, the details aren't that important. The gist of it is what matters. The virtual machines that we booted earlier are up. And then here below are the containers that are running on these virtual machines. So this particular virtual machine has a load balancer, a Node app, and a MongoDB node running on it. And if we go to its public IP address, the app is running. Okay. Okay, and it works. And it's fully replicated. So if you go to the IP address of a different VM, then the state we stored in the first one, you probably can't see that very well. The state we stored in the first one shows up in the second, and everything works, which is great. Cool. So that's how easy it is to deploy an application. Now that I've talked about what the blueprints look like, I'll show you the actual ones we used really quickly and walk through those. So this is the blueprint of the infrastructure that we ran. So inf.js exports a function that takes a number of virtual machines you'd like to deploy. This is some boilerplate. We declare that we've got a bunch of virtual machines running on Amazon. We're going to create count of them, which is a function argument here, and then return that infrastructure. And just like I showed earlier, if we want to run on DigitalOcean or something else, that's as easy as changing the file, and then you can rerun the spec. And here you can see that we're showing a diff of what the old blueprint did in the new blueprint. The new blueprint has a bunch of VMs running on DigitalOcean. The old one had a bunch of VMs running on Amazon. So if I click yes, it's in the process of tearing down the application and booting DigitalOcean VMs. Yeah. Okay. And then I'll show you the actual mean spec. So this is what we actually did Quilt run on. Just like any Node application, it's importing libraries. So this is a description of how HA proxy works. This is a description of how MongoDB works, Node.js, and then the infrastructure. Here we sort of make function calls in those libraries. Those function calls under the covers are going to sort of declare container objects and network config. But as a user, as a writer of this spec, I don't have to understand all those details. It just sort of happens under the covers. And then finally, we sort of allow these things to connect together here before deploying them. OK. Cool. So that's the demo. Back to the talk. So wrapping up, status of the project. It's an open source project licensed under MIT. You can find all the details of it that you'd like at quilt.io. We're still working on the website, so check it frequently. I'd say it's sort of alpha quality software. It works. Our own website is hosted on Quilt. You may not want to run a big production website like OpenTable on it yet, but we'll get there. And it's rapidly evolving. Like I said, I'm a networks and distributed systems person. I'm not a JavaScript person. I'm learning quickly, but the API will evolve to become more idiomatic JavaScript as we learn more and get better at this. And then, the reason I came to talk to you guys is I just would really like feedback. Try it out. Let us know what you think. Are we on the right track? Is this a silly idea? Feel free to email all of us at dev@quilt.io or me directly, ethan@quilt.io. Obviously, you can find us on GitHub at quilt.io. And if you would like to run some sort of system on Quilt, I'm happy to sit down with you and help you get it set up. I just want to make it as easy as possible. And with that, thank you very much, and I'm happy to take questions. Yeah.
If you do any questions, just repeat them after.
Okay. Cool.
Hi, I noticed that you had shown that containers were running on each of the virtual machines.
Yep.
Does that imply that you're actually running Docker containers under the hood?
Yeah.
Is it three on each one? Is it some kind of load balancing thing?
Yeah. So Quilt runs Docker under the hood. The way I wrote the spec, each tier, we put a load balancer on each VM. That's not required. That's just how I wrote this demo application. So we kind of had it load balancing. So if you went to a particular load balancer, it would go to one of the 4 Node.js apps on the other VMs and then go to one of the 4 MongoDB clusters. That's just how we configured it. But under the covers, we're using Docker. One way to think of the project is we're sort of a layer above Docker and Kubernetes and things like that just make it easier to use than running it directly. Yeah. Yep.
There was something weird about the deploying Mongo and deploying MySQL for a stateless application.
Yeah.
I'm not really persisting my data there, am I? Or what's happening there?
So right now what happens is the data just stores on the virtual machine that the containers booted on. When we add support for volumes, you can sort of, we sort of boot the Mongo containers and they're replicated. And if a particular container dies, the others sort of replicate the state. If all of the containers in your cluster die, then you lose the state right now. When we sort of add support for volumes, then this should become a little bit more robust. But sort of managing your state in a way that can sort of survive the failure of the entire Quilt cluster would be a challenge right now. Yeah.
A related question to that, Mongo and MySQL were the 2 example DBs.
Yeah.
They both have kind of notorious defaults.
Yeah.
They're like, I'll share your data if I feel like it.
Yeah.
How would I config? It's so easy. You just install Mongo. But how do I set? It has a lot of config settings, and MySQL too. Where do I do that?
Yeah. So that happens in the Docker container. So in our particular example, we have a sort of Quilt MongoDB container that has reasonable defaults for this system. And that's fine. The idea of the project is a MongoDB expert can configure a Docker container and then configure the infrastructure around it to run it. And you, as a user, can be sort of ignorant of all that in theory. That's the plan, at least. But yeah, this is a really difficult problem, particularly for databases. We have some sort of future work we're working on around being able to sort of express how to do configuration of the system in the Node.js. But right now, that's all done in the Docker container as it boots. Yeah.
So to repeat that back, if you did try to go to production, you probably wouldn't use Quilt/Mongo. You would fork it, write your own thing, and deploy that? Because that's how you configure Mongo, and Mongo must be configured.
Well, I think the hope would be that I'm not sure Mongo must be configured. I think the hope would be that there would be a Mongo Docker container that's sort of designed to work with Quilt, that's been configured for that infrastructure. But again, this is a very sort of researchy early project, so that's still something we're working through. I'm not claiming to have it fully worked out yet. But
Right, I guess my feedback is Mongo must be configured.
okay.
There isn't a perfect default for all production websites. That's not a real
I believe you, and we need to look into it more carefully. Yeah.
This is maybe coming another angle on the question of persistent state.
Yeah.
So you take the approach that this is basically, even though it's Node.js, this is a declarative blueprint.
Yep.
Okay, and as you elaborate the API, you will maintain that declarativeness. Namely, it's not going to be Turing. Your blueprint schema mechanism is not going to be Turing equivalent.
Right now, it's a Turing-complete language that
At the level of abstraction.
that generates a large data file, basically. Yeah. So the idea is that a Turing-complete language is more comfortable than writing sort of a JSON file directly.
But equivalent. Maybe JSON would
It's more broad, yeah. Yeah.
I mean, you've got recursion waiting to happen there.
Yeah. And this is actually how much programming language stuff needs to sort of make it all the way to the deployment engine. I actually sort of consider a research problem. Like, it's something we're thinking about and kind of interested in. It's just sort of underexplored. We haven't thought about it. Or we don't, right now it generates a data file, and adding more sort of Turing-complete stuff to this or intermediate layer is something we have to think about more.
In any case, that description is static with respect to operation.
Right now it is, yeah. I don't know if it will be forever. But.
One more? What's the academic motivation, or why does this have support, presumably, at Berkeley?
It had support at Berkeley because I was a student at Berkeley and I did it. Academic motivations. You build the product and then you try and write a paper around it and you come up with some idea. The main sort of, the main sort of way we've described it to the academic community is really comparing it to using YAML files to describe things. And just sort of saying that YAML files don't have any basic abstractions for describing applications. So if you look at Kubernetes, you'll see like people hard code version numbers in 15 places in 5 different files and things like that. And we're just sort of saying like, look, like programming languages exist and they have abstractions, so we should just use it. We haven't sort of published this anywhere yet, so who knows if that motivation will work. We'll try until we do. Yeah. All right, I think that's, I'm being kicked out, so thank you very much. And please find me after, I'd love to talk. Yeah.